Hi guys, in this video we're going to be looking at the uses for cells, alkaline hydrogen fuel cells, and the pros and cons of these hydrogen fuel cells. Finally, we'll summarise.
In other videos we've talked about the chemistry of chemical cells, how they work and how they involve redox reactions. They're used a lot in everyday life. The first example are non-rechargeable cells. You'll probably have called these batteries your whole life, and they power everything from remotes to games consoles, and even things like doorbells. They work by a chemical reaction, usually between zinc and ammonium ions. Remember that when we have the two redox reactions laid out like this, with the more negative standard electrode potential on the top, we can use an anti-clockwise rule to decide how the reaction will happen, and that leads to this reaction equation here, where zinc reacts with ammonia to form zinc ions and ammonium plus hydrogen gas. The way these cells work is to effectively have one of the half cells in a central ring in the middle of the battery and the other of the half cells on the outer end of the battery. When they're put in a device, there is then a connection between the positive end, the connection to the positive terminal, and the negative end, the connection to the negative terminal. Electrons can flow and the reaction will start to happen and the battery will discharge. This is how they give us electrical energy, and when all of the chemicals have reacted fully, they are then spent and disposed of because they cannot provide any more electrical energy. We can compare normal batteries or cells to rechargeable cells. For example, here's a picture of a car battery. In science, the difference between a battery and a cell is that a battery contains many cells. Each one of these things you can see here in the picture is a cell, and when we stack them back to back to increase the voltage they can give, we've made a battery. Rechargeable cells work in very similar ways to non-rechargeable cells. Chemicals react and generate electricity. However, the difference comes is that with these chemical reactions, when we apply a potential difference, so for example when we plug them in to charge them and we apply a voltage in the opposite direction to the direction in which it was discharging, then the chemicals regenerate. This opposite voltage pushes the reaction back the other way. Some examples of this include nickel and cadmium batteries, usually shown as NiCad, and these are used as rechargeable batteries in things like remote controls and toys. Lithium-ion batteries are lightweight, and they are used in laptops.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the Snap Revise smiley face here. Join me today, and together let's make A-level chemistry a walk in the park.